This lesson is about how to simplify numerical radical expressions. Let's review a definition. The product rule for radicals states that the root of a product is equal to the product of the roots. Here's the formula. The square root of m times n is equal to the square root of m times the square root of n. So you can break apart the square root across a product. For example, the square root of 12 is actually the square root of 4 times 3. So you can break apart the root into the square root of 4 times the square root of 3. And you can simplify the square root of 4 to 2, so your final answer is 2 root 3. Another example, the square root of 50 is actually the square root of 25 times 2. I chose 25 times 2 rather than 5 times 10 because 25 is square rootable. It's the square root of 25 times the square root of 2. I can simplify the square root of 25 to give me a simplified expression, 5 root 2. This product rule is especially helpful when you need to simplify a root that does not have a whole number answer. For instance, the square root of 16 equals 4, which is a whole number, and we all like that. But the square root of 12 is 3.464101 ... which is an irrational number that continues infinitely. Rather than expressing root 12 as an infinitely long irrational decimal, you could also simplify the root and just say the square root of 12 is equal to 2 root 3. We say this is simplified much like we say that 5/10 can be simplified to 1/2. We all prefer 1/2 rather than 5/10. Similarly, we will prefer 2 root 3 to root 12. In order to simplify a root that does not have a whole number answer, you must rewrite the number as a product of a square number and a non-square number. Let's just review the square numbers. The first few square numbers are 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, and so on. These are our square numbers. So, let's simplify some roots. The square root of 8. I will rewrite that as 4 times 2, because 4 is a square number, and 2 is not a square number. Now I use the product rule to break apart the root into root 4 times root 2, and of course the square root of 4 is 2, so it simplifies to 2 root 2. Here's another example, the square root of 20. I can rewrite 20 as 4 times 5. I chose 4 because it's a square number, and 5 is a non-square number. So I break apart the root, root 4 times root 5, and I can simplify the root 4, so it's 2 root 5. Review the example for root 12 and try root 24 on your own. Also notice these examples are all divisible by the square number 9. So root 18 can actually be rewritten as the root of 9 times 2. 9 is a square number, 2 is not. So the square root of 9 times the square root of 2, and it's 3 root 2. That is simplified. Review the following examples, try root 54 on your own, hit pause, and then proceed when you're ready. Here are some more practice problems. Notice that each of these problems you can rewrite the number as divisible by 25, such as root 150. Root 150 I can actually rewrite as root 25 times 6. So then I can break apart the root as root 25 times root 6, and root 25 is 5, and the root 6 just stays there, so my simplified expression is 5 root 6. Go ahead and try the following examples. They're all divisible by 36, and these examples are divisible by 64 or 81. Hit pause until you're done, and then proceed. These are all of the answers, so you can check your work.